Hi there. I hope you've watched the first part of this video because this is like the most important section of the course. Like, I'm being serious. Once you understand how the allocator works, the techniques are super easy and they fall right out. This first exercise is called Repair the Chunk. In this exercise, our goal is to fix a chunk that has been corrupted. And the goal of this is to demonstrate that you're having a good understanding of how chunks are actually structured and the information that's returned to you as a developer. So we are on a different screen. Yeah, there we go. This is my Bash terminal. And again, we're going to be doing the course from this Docker container, but you're more than welcome, and I've even encouraged it to do it in the VM. So the first thing we want to do is we want to look at the actual challenge. Now, everything's just going to be a C file that's pretty small for the most part. The challenge is maybe a little bit bigger, but besides the final challenge, everything's going to be less than like 100 lines of code. So here, we're going to make 3 allocations. We're going to allocate Malloc, or a chunk of size A0. And notice we actually requested 90. What's going on with that? Well, we need room for the size and prev size. So it has to have a buffer of at least 8 bytes anytime it makes an allocation. So hex 90 turns to a size of A0. Hex 100 will turn to a size of 110, and then hex 10 turns into hex 20. Besides the 8 bytes we need, it also needs to be 16 byte aligned. Here it's going to print out the addresses of these pointers. If you want to make it harder, you can also free the previous chunk, but I didn't do that here. And then we are subtracting hex 10 by the pointer of current, which is going to be the second chunk that we allocated. The reason we're doing that is because we want to get access to the prev size and size data. It's going to print out the pointer to the actual chunk, and then we're going to memset the chunk. So we're actually clearing the prev size and size of this. Finally, we're going to read in 16 bytes into chunk so that we can fix it. And then we're going to free chunk. And it should be noted, free only works if the chunk is legit. If you've done something funky, it doesn't like it. So you have to do something correct. You have to write the data in here correctly. Now we have the start.py file. And I'll go through this once just so we know what's going on. It is using a version of libc called with 2.23. It is using LD preload in order to load that particular version of libc instead of the one that's on the system. It is then using pwn tools to start the process with GDB. And then this dir here gives you source code access to libc. So if you want to like step-by-step go through libc, you can. Every exercise will have very nice comments like this that really explain how stuff works. Please read the comments. I intentionally made them helpful. I'm not trying to trick you with anything. So here, we're doing a send line, and this is going to send the bytes we put before it. The first one is the prev size. For weird reasons on the free, that you probably don't know yet, we actually don't care about the prev size. If you would like, you are able to do this, but because the chunk below us is free, we don't actually need to, the chunk below us is allocated, we actually don't need to care about this, which is why the second challenge, if you want, is to uncomment that free because it makes this harder. Now here is the size. So you need to fix this so that this actually works. You need to give it a size that is correct, otherwise the perm will crash. And most of the exercises, you're just going to want to fill out the to-dos. There are going to be a couple of fill in the blanks, but you really understand what's going on. So if I start this and I do continue, we can see it has some printouts, what the original size was, hint, hint. But we can also do nice things like this. So I didn't show this in the slideshow a second ago, but there are various commands that are really helpful. The first one is the heap command. This will show you the state of the heap at that current point. If I scroll up after running that command, we can see that there are indeed three chunks. There's A0, 110, 20, and then the top chunk, just like we talked about. We have symbols, and so we can also do like print current, and this will give you a pointer to that, which is really nice. And show you the data that's there. What else is helpful? You can do viz heap chunks, and viz heap chunks gives you a color-coded version of this, where it shows you what data is where. Now if we do continue, and it's cleared the previous size and size, if we do heap now, it gets really confused because the second chunk is now set to 0. And if we do viz heap chunks, like before, it's also confused because the next chunk should be 0 and it's not there. So clearly we've corrupted this. And this is a really good way to debug the heap and what's going on. So I recommend doing that. There is also a solution doc if you don't like watching me talking videos about it too. Cool. So that is the exercise. Good luck on the exercise. If you get stuck, watch a solution video, look at the solution.py file. That'll be good. Thanks.